Good day, everyone. So today we'll be diving into skills and skill drawing. We shall be mastering the fundamentals of accurate measurement and proportional representation in technical drawing. All right. So let's first of all talk about the first instrument here, and that is the meter rule. The meter rule is a flat measuring device. Okay, something like this. We might have seen this before. Made up of wood. We have some of them made up of plastic, and some other type are made up of metal. So any of this material can make this instrument. All right. You can have the wood type, the wooden type, the plastic type, and the metal type. Well, whichever way, whichever material, they have on them what we call gradation. All these vertical lines are known as gradation or calibrations. Okay, and they are either in millimeters or in centimeters, right? But the only time you call a ruler meter rule is when it's between 0 to 100 centimeter. Any ruler that is from 0 to 100 centimeter is called a meter rule. Of course, from our metrics table, we know that 10 millimeters make 1 centimeter. So if you're going to convert from one um, unit to the other, you can make it of this metric formula. So 10 millimeters make 1 centimeter, and of course, 100 centimeters make a meter. So a meter rule is actually one of the measuring instruments that we use in our scale and also our scale drawing. Okay, how do you make use of the meter rule? Step one, you place the meter rule along the line to be measured. For example, look at the meter rule here now. Maybe you want to measure the chord of this circle. You place the meter rule along that chord so that it will be in parallel with that chord. Okay, you can see it here. After the first step, the next step is to make short dashes at right angle during the measurement. So having done this, having placed your meter rule along the line of along the line to be measured, then you now mark with right angle like it is shown here. You mark that point with what? A right angle, vertical line like this. Mark the other side too like this, vertical line. You don't put dots. You do not put dots there. You mark it with a vertical line. That's why we say make a short dash at right angle. So you mark that place as with a short dash to be in form of right angle at the first end and the second and the other hand. Then you double check your dimension for accuracy. Be sure that you are not making mistake. You know, that's what we call a parallax error. When you are double checking, you make sure you avoid parallax error, meaning that you are not viewing from an angular position. That's the double checking aspect. Ensuring that you are getting the exact measurement you mean to measure. So having done that, having marked the place, then you can now take away your ruler. Now, caution, never use compass or divider directly as being used here. Maybe you want to measure this length, you now get a divider or a compass and use directly. No, it's not allowed. You use your ruler, then having used your ruler, you can now get your pen and mark out the place. Do not use compass or divider to mark directly. To mark directly, it is not allowed. It can damage uh, the drawing board. It can damage the paper and so many other um, negative effects when you are using the meter rule. Okay, so do not. You can even destroy the meter rule as well. So do not use the divider directly on the meter rule, right? So Going forward, let's talk about dimension notation standard. First of all, we don't write unit in capital letter. For example, now we have something like centimeters. You don't say capital letter C and capital letter M. No. Unit are written in small letters. Okay? So centimeter has small letter M, small letter C and small letter M. We also have millimeters, small letter M and small letter M. So it shouldn't be in capital letter. And when you have taken measurement, as you could see a sample here, we don't normally put the unit of the dimension beside the values. You could see this 10.5, not unit. What do? You note your unit at the title block here. Okay, so the units are not written beside dimension. They are always noted on the title block. And then if your dimension is lesser than 1, you do not write 0.25, for example. You write 0.25. 0.25 is not allowed. Any number, any dimension that is lesser than 1, you use 0, then put decimal point. 0.25, 0.25, 0.45, 0.85, and not 0.25, not 0.45, not 0.85. So this is the rules that guide our scale drawing in basic technology. Right. Now, what is scale drawing itself? Scale drawing provide accurate representation of objects by using proportional reduction or enlargement. Unlike ordinary sketching, scale drawing maintain precise dimensional relationship, making them essential for technical and architectural work. When you are dealing with scale drawing, it does not change anything about whatever you are intending to draw. You can choose to draw a very mighty building on your paper, but with the help of scale drawing, whoever is going through that scale drawing will be able to know the exact fitting of that building looking at your scale drawing. All right, so it provides accurate representation of whatever object, whatsoever object, it gives you the accurate representation of the object that you are intending to draw. But sketching will not do that because sketching does not give accurate representation. Alright, so that's the difference between when we are sketching that we learned in our last class and when we are having scale drawing. If freehand sketching, there is no accurate representation of what you are drawing, but scale drawing, you have an accurate representation of exact diagram or image that you are drawing. Alright, now let's talk about the essential drawing tools we need for our scale drawing. Just two of them. The first one is the metric rule. That's the meter rule we talk about. Okay, the two flat straight edges that the meter rule. Look at it here. This first one. Okay, 30 centimeter long for precise measurement. So in this case, is usually 30 centimeter long. All right, but sometimes you can choose to make use of your meter rule too. And the second drawing tool is called the scale rule. Is triangular in shape, and each side of the triangle has graduation. This calibration there you can see here, that's here, and that's on the other side too. So these are the two major drawing tools for scale drawing: the metric rule and the scale rule. Okay, I would say that let's now talk about type of scale. We have three major type of scale. We have the full scale, where you have the actual object being drawn the same way it is. We have the reduced scale, when we need to reduce the size of the actual object. For example, now this building, I'm going to draw it in a paper. I will use what we call the reduced scale because the size of this building can never be represented in a paper. exactly. It will be too big. So that we need to use a reduced scale. So this is the actual scale, but this is the what? The reduced. This is the main drawing. Okay. This is the actual object, and this is the main drawing that we reduced so that it can contain. Then what we call the enlarged scale. We use this for small objects. For example, now maybe you want to draw a mosquito. So mosquito or ant, they are so tiny, so we need to use enlarged scale to make them big. So this is the actual object here, but this is what will be in the drawing, a bigger version of it. So we have the full scale drawing, the reduced scale, and then the enlarged scale. Now talking more on the reduced scale drawing, like I said before, it's used when objects are too light to fit on drawing paper at actual size. If you want to draw uh, you want to draw four-story building, all you would need to use is reduced scale drawing because your four-story building cannot be contained in your A3 paper. All right. So you have to use a reduced scale drawing that will reduce that four-story building into a smaller object. An example of such is 1:2 scale. This simply means the main object, okay, have been represented by half of it, okay, half of the actual object. So if the object was actually, let's say 20, you will use 10 to represent it. So that's what it means. 1:2 simply means half of the actual size has been drawn. 1:10 simply means 1/10 of the actual size is what is in the paper. Okay, so this is how we represent ratio. Then 1:100 scale simply means 100 of the actual size is what you have on the paper. If you see, look at this case. Now this is a big object, but it has been reduced to this size in the paper. And the reason is because we want the object to be contained in the paper. So that is the reduced scale drawing sample, like we have mentioned earlier. And at the other hand, we have the enlarged scale drawing. We use this when an object is too small to show details clearly. Like I said earlier, so the object dimensions are proportionally enlarged. Okay, for example, now we have something like 1000 millimeter ratio 1000 meters ratio 1 millimeters. Okay, so it means that for every 1 millimeter on the drawing, it will be saying 1000 meter in actual size. Okay, that's what it means. So wherever you see 1 millimeter in the drawing, so it actually means 1000 meters of the actual size. We have other sample too. This 1000 ratio 1 scale, it means 1000 times the actual size. Okay, so if you see the object, if you see the drawing having 1000 ratio 1, it means that for you to get the actual object, okay, you have to divide by 1000 to get the actual object. So this is the actual object, and this is what is in the drawing. So 2:1 scale simply means that the diagram or the drawing is twice the actual object that they are drawing. So by the time you want to get the real object, you divide, okay, by 2. This 100:1 scale simply means that the drawing is 100 times the actual size. Okay, so in this case, we enlarge the scale we enlarge the object in the drawing. That's what we call the enlarged scale drawing. All right. So in summary, we say that scales are expressed as ratios, as we have seen, and they are stated in the title block. So we don't normally, put scale in the drawing. We normally put the scale in the title block so that whoever see the title block, whoever see the scale drawing in the scale in the title block will be able to, know the exact size of the object, whether it's a reduced scale or it's an enlarged scale. This standard notation ensures anyone reading the drawing, like I said, understand the proportional relationship between the drawing and the actual object. All right, so this is where we shall be drawing the curtain for today. Yeah, thank you for listening and bye for now.